Okay, for today we're doing probabilities, and there's a lot of terms that you have to know. You have to understand experimental versus theoretical probability, and we're doing a lot of stuff with tables. All right, so here's some vocab, and I had the students read through these. I think you get what random means. Random means that you can't control it. It's just gonna come up equally likely that any of the possible outcomes of the event, it's equally likely that they would all happen. Okay, and this has no individual outcome is predictable. You can't predict ahead of time what's going to happen. That's what random means. All right, so the dice one, this is one that a lot of people misunderstand. They think that rolling a seven, when you add up the two dice, is equally likely as like rolling a 6 or rolling a 5, because you never really notice, because you never really took the time to think it through. But there's only one way to get a 2. And there's 36 different things that could happen when you roll 2 dice. And I know some people think, but the only things that can happen are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. But there's really what's happening is there's 6 different things that could come up on the darker colored dice, and 6 different things that could come up on the lighter colored dice. And when you multiply those together, you get 36 possible combos. All right. So 7 is by far the most likely number to come up. So when you're in Las Vegas and you play that game called craps, where you roll the dice down the big green table, and if you roll a 7 at the very beginning of the game, you win, and everybody around the table is happy. Yay! Okay, but you typically roll 3 or 4 times, and if the 7 ever comes up again, everybody loses. So they make it so that there's only one chance for you to get a 7, and that's at the beginning, the first time you roll. And all of the next rolls that you do, whenever a 7 comes up, you automatically lose. In fact, they make another number. If you get an 11, that also you automatically lose. So do you get that they have 6 things here, 7, 8 things here, out of 36 possible things? 8 things that could happen make you lose after your first roll. And they make it complicated on purpose so that you can't just tell that you're not going to win. Like if they had, I don't know, a 6-sided die, and you could roll the die, and if it was a super easy game, you could figure out your probabilities, and you probably wouldn't even want to play because you'd know it's rigged against you. And that's what happens in Las Vegas. All the games are rigged against you. But they make them complicated enough that you can't quite tell. And it isn't super obvious that it's rigged against you, but it is. All right, let me give you this example. Let's say that you can bet on what's called a hard 8. A hard 8 is an 8 the hard way, is the way they describe it. And an 8, here's an 8. You're not even just betting that 8 comes up. I swear half the people who put the bet probably even think that they win if an 8 comes up. No, you only win if you get 8 the hard way. Which of these do you think is 8 the hard way? The 2 4s. That guy right there. So you're really not betting on an 8 at all, because an 8 would have had 1, 2, 3, 4, 5 chances to win, but you're betting on the 1 doubles that makes an 8, so there's only a 1 in 36 chance you win. Now you get a good payoff. It's not just like I put out $1 and I get $1 back. It might even be 10 to 1. They maybe pay you 10 times. You put out $1 and you win $10 if that happens. But what's the probability of getting a hard 8? 1 in 36. So they really should pay you $36 for the $1 that you bet. But they're only going to pay you like 10. So, moral of the story, all the bets, again, are rigged against you in Las Vegas. In fact, I think there's one bet that is actually even odds. It's like fair. And that's literally one bet at one type of game, and it can only happen at one part of the game. And so they make it really hard for you to have any advantage in Las Vegas. The absolute best chance you have is fair. And it's really even hard to find that one thing that's actually fair. All right, so let's move on to this. If we ever do cards, we'll put up something like this, or you can ask me. Because a lot of people know there's 52 cards in a deck, but other kids don't. And if you don't play cards a lot, you can ask me anytime we have a card question. You can say like, how many black cards are there? And I'll tell you. Okay. And there is 52 cards, so there's 13 of each. So 13 of these, 13 of those, 13 of those, and 13 of those, and that adds up to 52. And there's 4 kings, for example. 1, 2, 3, 4 kinds of kings. But again, if you ever need that, you can ask me. All right. Sample space. That's one of the weirdest ones. You remember that list of 36 things that can happen on the die? That's the sample space. It's all the things that could happen. What if I'm rolling 1 die? Well, then the sample space is 1, 2, 3, 4, 5, or 6, because those are all the things that could happen. So a list of all the things that could happen, that's called the sample space. The probability, I have my own definition that I like better than the measure of the likelihood that an event will occur, because I can show you how to get it. But I'll give you my definition in just a second. One thing that's really important is these are always decimals. And your answer for a probability question in our unit cannot be a fraction. You have to divide them and get the decimal. Okay, so if it turns out it's 6 ways to get a 7 out of 36, you can't leave it like this. You got to actually divide them and get the decimal. This is like 0.164 or something like that. Okay, so it's always going to be a decimal. 1 is a guaranteed, like, what is the probability you're going to get 1 or 2 or 3 or 4 or 5 or 6? Well, that's a 100% chance. That's 6 out of 6. So that would be a 1. There's not many things in the real world that are 100%. There's not even a 100% chance that the sun's going to rise in the morning. Sun could blow up overnight, possible. All right. 0, also really rare, but in math it happens. Like, what's the probability I'm going to roll a 7? Well, there isn't a 7 on the die. The probability of rolling a 7 is 0. Okay. You could roll 2 dice and get a 7, but not 1. All right. So I want you to write this down. Please write this down. Probability equals what you want over what's possible. And these are both outcomes. Now, you don't have to remember the outcomes word. They're wanted outcomes over possible outcomes. So every problem we have today, every one of them, you're going to have to figure out, what do I want to happen over how many things could happen? So when you got a die, what do I want to happen? Let's say that you want an odd number to come up. Then you'd have 3 wanted outcomes over 6 possible. So 0.5 is your probability that you'll get an odd number, okay? Let's say I was doing it in this class and I wanted to do it with the probability that I randomly pick a kid and they have white shoes. How many of you look at your shoes would say, I have white shoes? Raise your hand if you would say you have white shoes. I mean, predominantly white. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so then there's 8 out of 24 of you today. 8 out of 24 chance, because there was 8 that I wanted, which people with white shoes, out of 24 kids possible. So when they get complicated, which they will by the end of the hour, you got to ask yourself, what's the things that I want, and how many of them are there? How many things are there that are like what I want out of what are all the possible things? All right, move on to this page. Experimental versus theoretical probability. I have no idea what the probability of you having a cat is. I have no idea. So how could I get that? I could do an experiment. Let's do it. How many of you have a cat? Just raise your hand if you have a cat. All right. 1, 2, 3, 4, 5, 6, 7, 8. Do you get that out of 24 of you, there's an 8 in 24 chance that you have a cat? Now, could I get even better data if I asked every kid at the high school, do you have a cat? And then I have better data. Maybe this happens to be not a random selection of kids. Maybe this has a bias because it happens to be more cat owners in here than normal. But you can do an experiment to find your probability. Sometimes you actually can get a theoretical probability. Like if I said, if I have a normal coin, it's got a heads and a tails. What's the probability you're going to get heads? Yeah, 1/2, which is 0.5. You know that one. Because why? Because you can do it theoretically. Sometimes you can get theoretical probabilities. But you can even have a theoretical probability of 1/2, and yet if I flip a coin actually 10 times, do you get it's very likely that I won't actually have 5 and 5. You know, it's the most likely thing, but isn't it also pretty likely it'd be like 6 and 4? So that was the experiment can sometimes come out different than the theory. In theory, you should have 5 out of 10 rolls should be heads, or flips should be heads. But in the actual experiment, it might come out different. Okay, that's experimental versus theoretical. You have to know that one. That's for sure being tested. And now we're to the last thing I have to teach you, which is kind of cool because we're only 15 minutes in. And the reason that we're going fast is that today was easy and we have to fix a test question on the test. So I'll explain that to you in a minute, but we're going to be wrapped up with the homework and you'll be in the homework in like 5 minutes here. And then we'll have something else we have to do to fix yesterday's test. All right. So let's talk about this. Let's say this is all the students that I teach. This is actually true. I actually teach around 100 kids here. This year I have a part-time schedule, so I have about 100 kids. Okay, and I could very easily believe that there's far more righties than lefties. And on the freshman sophomore thing, really does depends on the class. Sometimes I have more sophomores than freshmen. Sometimes there's more freshmen than sophomores. So I'm not too surprised. This all looks pretty accurate for me. This is my data. So if they asked how many people were polled, that's not a probability. It's just a simple question. What is the answer? Say it if you know. 100. 100 people were polled. All right. How many freshmen were polled? Take a second and write down all these answers. How many freshmen were polled? If you said 43, you missed the point. What's the actual answer? 52. 52 freshmen. That's there. How many sophomores were polled? 48. That's pretty easy. How many right-handed people? Just getting used to reading these charts. Right-handed people are there, and 87 is the total of them. Very good. Lefties, 13. Okay. How many people were a sophomore and left-handed? Sophomores and left-handed. Do you see that this is the spot? All right. So do you get in this room? There's probably a left-handed sophomore. I'm not saying there is for sure. There could be. All right. And what's the probability of it? Well, if this really is good data, then there's a 4 in 100 chance that if I pick one of you, that you are a left-handed sophomore. Do you get that's not a high probability? 4 out of 100? It's pretty low. All right. Okay. Now, these get way more intense on the next. Go to the next page. What's the probability that a person polled was left-handed? Now, all of a sudden, it's a probability. So now it's what I want, all the outcomes that I want over what's possible. The lefties, that's 13 out of 100. You guys get that? That makes sense? 13 out of 100. How about the probability that the person polled was a sophomore? Sophomores, 48 out of 100. Now, careful. That's the easy kind. Sophomores is 48 out of a total of 100. But as soon as they say given, watch out. Pay attention to this now, because it's not out of 100 anymore. When they say given, this is called a conditional probability. On the condition that a person has to be a freshman, what that means is you narrow it down and you circle just the freshman and you only use these 3 numbers. Do you get it can't be out of 100 if you're going to only use those 3 numbers? That's what they mean when they say given it has to be a freshman. They're narrowing it down to just those 3 numbers. Now, what's the probability that they're right-handed? It used to be 87 out of 100, but now it's 43 out of 52. Do you get the difference there? So watch out for given because it changes what it's out of. It changes the bottom number every time. So please, without my help, answer number 4. It's a given again. It won't be out of 100. And this time you can give your answer as a fraction just because I don't want you to have to deal with going and getting the calculator out and all that. So write your answer as something out of something which you would have divided. And please talk to the kid next to you about the answer to number 4. So as soon as they said given left-handed, it was only those 3 numbers. And then what we wanted was lefties, but sophomores. So those are the ones I wanted, 4 out of 13. Okay. All right. Now this is an important concept, the or. I want to do one before we actually answer that one. I want to show you how it seems like this or that would be a lower probability because it has like these 2 things. And this it seems less likely, but or means a big answer. And I'm going to show you why. Raise your hand again if you had a cat, and keep your hand up. Now if I change the question to raise your hand if you have a cat or a dog. See how it got way bigger? The probability just went way up. Okay. And if I go, the probability you have a cat or a dog, or you drove in a car today, or you drove in a vehicle that had 4 wheels, or you have hair. Pretty soon I've got everybody. Okay, so if you add or, it gets bigger and bigger and bigger. So when you're answering these questions, don't think of this as getting smaller. It gets bigger every time you do another or. Right-handed or freshman, it got bigger. The probability went up. Did it say given anything? No, so then it's out of 100. It's out of all the people. Given what I just told you, it's out of 100. Try to figure out the answer to this question. It is not super easy. All right, so I totally get people go right-handed freshman, and they go, here's the freshman, and here's the right-handed people. So I add them together, and I get 100 and something out of 100. Do you see how that doesn't make any sense? You can't do that then. You can't just take the totals of the right-handed and totals of the freshmen. That doesn't make sense. Don't use your totals. Instead, look at your not total numbers. It'll be these 4 are the actual people. The other things are all totals. And then you ask yourself, who is right-handed or a freshman? And you can ask these people, are you right-handed or a freshman? And they'd be like, yes, they're in the group. Are you right-handed or a freshman? Yes. Are you guys right-handed or a freshman? Are they? Yeah, they're one of the 2. All you have to have is one of the 2. Are you guys right-handed or a freshman? No, so they're out. So then it's those 3 out of 100. You get how I did that? And it's a big answer. It's almost everybody. It's everybody except 4 people, in fact. Because these are the only people that didn't qualify. So then it would be 96 out of 100. Who had 96 out of 100? Nice job. Okay. Good. Go on to this page. And this is about sweet and salty. And at first I was confused because a lot of people have a phone and a laptop and a tablet. But what they're asking is, if you have a choice and you could only bring one device with you, like on the plane, okay, you get to pick one of these devices. What do you want? They had to pick one. Okay, and they could only bring one snack. You had to pick one. Would you rather have like potato chips or would you rather have like chocolate? Okay, so now let's answer some questions about it. Find the probability that a randomly chosen student, that means it's out of 135. Because they didn't say given. They didn't indicate any kind of a given. There's no condition on it. Preferred salty and a tablet. Ooh. Did you like salty and a tablet? What would they say? Yeah. You could ask these people, did you like salty and a tablet? They would say no. Did these people like salty and a tablet? No. They like salty, but they like their phone. And it's going to be like, oh. Do you get and answers? Are the opposite of or answers. Those are the small ones. Okay? So if I said, in this room right now, I already did the cat and the dog thing, right? You know, you guys probably know there's more dog owners than cat owners. Right? Pretty wide margin. Okay? So if I said, who in here has a dog? Would you raise your hand if you have a dog? All right. Now, keep your hand up if you have a dog and a cat. All right, so there's still like 4 of you. Keep your hand up if you have a dog and a cat and fish. 1 person still has it. All right, congratulations. See how it went down, down, down? If I say and, the probability goes down, down, down. So ands are small and ors are big. This will help you. I'm telling you. I know where you're going by the end of this unit. And small answers. And it was only these guys. 15 out of 135. And you have to divide them to get the decimals. Don't forget that. It's always 3 decimal places. Okay, I think you have the idea. Let's start your homework. Your homework has a big long worksheet and it's got basically 2 problems. We're going to do the first half of it. Just the first half. Why? Because we're going to basically eat up the rest of this hour. Some of you will be done in 5 minutes, but we're going to eat up a lot of this hour fixing the test. There was a mistake in the test, and I have to give you your test back and give you more time to make it fair. So anyway, we're going to finish that off right now. Question? Not right now because you're going to miss the critical test thing. So in a minute, yes. All right, so right now on your worksheet, find the worksheet. Find the first, it's like 10 questions, and then there's another 10 questions after that. We're going to start it together. We're going to do the first problem or the first set, and then find the last set and cross them all off. I think it's 1 through 10. Yep, it's 1 through 10 we're going to do, and then the rest of them you're going to cross off. All right, number 1, Isaac, would you please read the question for number 1?
Find the probability that a random chosen student preferred Dairy Queen.
Dairy Queen. So I want DQ. Did they ever say given? Given that they were a freshman. Given that, no, there was nothing like that. So then it's out of the total. How many is the total?
120.
So it's definitely 120 on the bottom then, because it wasn't a given. So you just find the biggest thing it's out of. And then, what was the Dairy Queen, kids?
25.
And if I wrote this on my worksheet, why would I get it wrong? Has to be divided and gotten into a decimal, okay? What is 25 divided by 120? There you go. Now, is that 3 decimal places? No. If you wrote that, I'd have to mark it wrong. Oh, what I usually do on a test is I'm not going to mark everyone wrong. If you like round up 4 places on the whole test, that'd be just cruel because you'd probably fail the whole test just because of rounding. But on that problem, I'd have to mark it wrong. And then on the future problems, I'd probably give you more of a break because, you know, don't want to kill your grade. But it should have just been 0.208. Get the idea? All right. As soon as they say given, it's not out of 120 anymore. Okay. All right, good. Now, this is really important that you stay with me because I'm now about to get you a little bit of a review before you finish the test. All right. So now I'm done with the video for today, and I'd like you to get out a blank notability doc.